So thanks everybody for hanging out, especially when we have Beer 30 and very soon. My name's Scott Tracy. I'm a director at Sun Microsystems. My partner here, Dan Maslowski, senior manager. We call him Demo Dan. He's going to do the demos for us today. Anyways, we're going to talk a little bit about COMSTAR and ZFS. How many people know about COMSTAR? All right. There's a few. That's good. Everybody knows about ZFS, right? About the same. Okay. All right. So the goal of this presentation. Now, I let Dan figure this goal out, and of course, this thing rambles on for like 4 lines. Really what I want to get out of this is how do I build a high-end array with commodity parts on the cheap, right? I mean, that's really what I want to get to. So all this is kind of Dan. So a couple of things too. Dan and I, and another outcome of this presentation, Dan and I are not ZFS power users. You're not required to be a power user really to get all of the innovations coupled with COMSTAR and ZFS, and that's kind of the beauty of everything. It's a simple administration model. COMSTAR is a very simple design as well. We're going to show you at the end how easy it is to get something up and running. So what's a full-featured array? I talk about with commodity parts, get a full-featured array up and running. Well, a full-featured array includes a lot of moving parts. So RAID 1, 5, or 6, this does not come, in fact, RAID 6 rarely comes in your low-end arrays. Data integrity checking, you get that for free through ZFS. Infinite snapshots, take as many as you want, as often as you want. Automated data validation, in other words, preventing bit rot, so you can go out and check your bits on disk and verify that they're in good shape. You get compression, automated backup using interfaces through ZFS. You can do that locally, remotely, or to tape. You get LUN mapping and masking. This is, a normal thing in RAID arrays, and I'll talk a little bit about that later. Thin provisioning, dynamic LUN expansion, and then multi-protocol access. This is something that's very unique to COMSTAR. For a particular LUN, the way that we put it together, you'll be able to access that through multiple protocols, and we'll talk a little bit about that as well. So, block target software in the industry today, pretty much all the same, right? You have a front-end transport that's usually an HBA. You have a SCSI command interpreter, something that breaks down SCSI commands and understands how to either respond to the host or send things to the back-end disk. You have a back-end transport, another HBA or host bus adapter, and then you have back-end disks, right? Seems pretty simple. So, and that's exactly what you get with COMSTAR and ZFS. So if you look on the right in green, the iSCSI port provider, the target mode framework, and the block LU provider. Port provider is basically the front-end transport, and those will be, as I've said, multi-protocol. So today we do iSCSI and Fiber Channel and OpenSolaris 2009-06. You'll see tomorrow that we're going to add more protocols. We've actually already integrated some new protocols, InfiniBand, FCOE, SRP, ISER. Those are coming in the next release of OpenSolaris. Then we have a SCSI target mode framework, sort of provides the glue between the front end and the back end. So glues the LU providers, and an LU provider is basically something that identifies itself as a D-type in SCSI, or hey, I'm a disk, or I'm a tape device, or something like that. That's what your LU provider is all about. The ZFS volume emulator, we call them ZVols. This is interesting. It emulates a device, but it's kind of a backdoor into ZFS. And what's neat about that is that you get all the semantics of a ZFS file system. So you get the data management, the DMU, transactional object database, and then you also get the SPA, the storage pool allocator. And along with the SPA, you get all of the data services that you'd get for any of the POSIX file system. So you get compression, you get all of those same tools, RAID, etc. So that's what makes this really powerful. So COMSTAR, again, just kind of refresh, stands for Common Multi-Protocol SCSI Target. Again, modular in design. The port providers, the thin layers that describe the individual transports. SCSI target mode framework, again, we talked about breaking down SCSI commands. Also does LUN mapping and masking. It does all of your abort, cleanup of commands, etc. LU provider, again, thin layer to describe any kind of logical unit. COMSTAR actually can sit on top of any file system, any raw device, actually even an SVM vol, but it's best when coupled with ZFS because ZFS brings so many other characteristics to the table. So ZFS, I probably don't need to say much about that. The ultimate backing storage, pooled storage, a new concept for file systems, but in this case the ZVol just eliminates the antic notion of volumes and having to deal with disks and all that good stuff. But it does for storage what the VM did for memory, right? Transactional object system, always consistent on disk. Again, it's universal, works with file block, COMSTAR swap, etc. Kind of as we showed in that other diagram. Provides end-to-end data integrity. Really important these days, right? It calculates a checksum with every piece of data that it stores. And very simple administration. So the array hardware. So my goal was to show you commodity-based array, very low cost, how you can put this together to be more of a high-end model. And we did have a little snafu today. We had shipped our commodity array out here. It didn't make it. But we did bring another array, and Dan, if you want to lift the skirt there, it's similar to this one, and definitely similar in cost. This is all Dan lifting his skirt. This is all commodity parts. We went to the HCL, looked up the different pieces to get a motherboard and hard drives and everything else. All the stuff listed there. Total cost $700. Right? And I think the point here, if you go out and buy a RAID card, you can do this with other things. Linux provides an iSCSI target, block target mode thing. Windows even has a storage server and that sort of stuff. But typically with these things, you've got to buy additional hardware to get the same features. So you'll have to buy, for example, a RAID card, right? And so $150 RAID card comes, 0, 1, and 5 RAID, but not 6. If you want 6, you're going to pay additional $450. All of a sudden, just that one RAID card is almost the whole cost of the system, right? So Taskmap, and it's pretty simple. Simple set of steps to get LUNs exposed to the outside so that you can connect with the client and use them as just a regular block device. Create your storage pool with ZFS, configure COMSTAR, and then you configure your data services. So in general, the data services are provided as interfaces, and then it's up to you to figure out how you want to administer them. And we'll talk a little bit about that, but just for an example, ZFS provides scrub. You can actually use a background task of using ZFS or zpool scrub, I should say. You can use that command if you want to automate it. You need to set up a cron job or something like that. So that's what you have to do with your data services. All right, so first step, create storage pool with ZFS. Really here, you're creating your pool, and then you'll do a volume creation or ZVol creation of the size and characteristics that you want. You can set certain properties on it, etc. Things like the RAID level, you have to make a choice up front on that, but then as you cut your ZVols, you can enable or disable compression and other ZFS properties. And we'll go through some of those steps. Configuring COMSTAR, pretty straightforward. Once you've got your ZVol backing store, you're creating your LUNs, and then you're creating your LUN, what I call LUN provisioning. In the industry, that's LUN mapping and masking. And I'll talk about what that means too. And then configure data services. So you can automate snapshots, you can automate your backup, you can do your data validation. As some previous presentations showed, you're going to be able to do other things with ZFS as they come out, encryption, deduplication, all of those things you'll be able to take advantage of. So a couple of decisions, at least for me, when I think about setting up an array, before you set it up, it's worth taking a little bit of time to walk through the choices that properly match, your characteristics that you want. So speed, resiliency, capacity, backup, security, all of those things you need to kind of take into consideration. And not to mention how much it's going to cost. So some of these choices you can change later. Some of them you got to make up front, and once you make it, it's hard to reverse out of them. And we'll talk through a few. There's a lot, so we're only going to talk through a few today. So anyways, next slide. So the first one is really RAID. And this one is, I've tried to draw a little chart here to give you kind of some rules of thumb. But again, these are just rules of thumb. So RAID 1 is a mirror. ZFS will allow RAID. A RAID Z volume is akin to RAID 5. It's not exactly the same as RAID 5, but it's akin to that. A RAID Z2 is very akin to RAID 6. And then just for completeness, I showed a RAID Z with a hot spare. You can actually set up a hot spare with mirrors, RAID Z, all sorts of different configurations. So a mirror volume is really, pretty quick. Out of all of those configurations, a mirror is one of the quickest, but it also chews up the most space. So you have to kind of make a choice. And it's only the quickest in certain I/O characterizations. So if your I/O is large and sequential, ZFS does a pretty good job of optimizing it for all configurations. There's not as much difference between all of these. But if it's small, choppy I/O, mirroring would be your best choice. So it's kind of hard, but mirroring is typically the fastest. You lose a lot in capacity, right? So for a two-way mirror, you're going to lose half of your disk to the resiliency. Your recovery, right, based on your in-way mirroring. You can do as many mirrors as you want. You can do a two-way, a three-way, a four-way, etc. But kind of after three-way mirroring, you start to really lose mean time to data loss coverage. It just doesn't mean as much past about three-way. A RAID Z volume, so you've got one parity disk. Basically, you've got one parity disk, and the rest will be your data disk, right? So you can lose a particular disk in your RAID Z, and then, if you lose one of those, ZFS can reconstruct from the remaining data. ZFS is a little bit different in this regard because RAID Z volumes are not typical as we see in RAID arrays today. You don't just set up, a certain number of data disks and one parity disk and do it that way. You actually have variable write stripes where that parity disk actually can occur on different disks across the whole pool. It avoids, the write hole and all of that good stuff because it does the write all at once. It's always consistent. But it's very similar to RAID 5, so I kind of use that chart to help people think through that. And then RAID Z2, just two parity disks, so you can lose up to two disks, right? In terms of speed, RAID Z is a little slower than mirroring. RAID Z2 is really very similar to RAID Z, so there's not much, speed. What you're looking for in making those choices is how many disks are you willing to lose? How paranoid are you, right? So do I want to be able to lose two disks or one disk, etc. RAID Z with hot spare, you don't get any additional redundancy, but you get automatic recovery. So that's an option for you to think about. And actually, kind of interesting too with ZFS, you can set up spares between pools too. So you can have a spare for more than one pool. So if you lost a disk in one pool, it takes it over. Another pool, it would take that same disk over. So that's a tough choice. This is one you can't go backwards on. You make this choice, you can't change later. You can't say, oh, the mirroring was cool, but now I'm going to go to RAID Z2. That's really not an option. You're going to have to offload your data set, reconstruct. Okay? So compression, squeeze your Z-vols. Compression, you can set up on each Z-vol. You need to think about what data you're actually going to be storing on the Z-vol. Some things don't compress all that well. Some things compress a whole lot better. For example, MPEGs, pictures, those sorts of things don't compress all that well. They're already compressed. In those type of situations, the compression would spend more time in CPU cycles than you would gain benefit on disk. But for the most part, most data is pretty compressible. So in those cases, actually I/O operations will go faster, right? Because you'll compress it, you'll send less data over the wire, and so that's great. You got a little bit more CPU utilization, but that's okay. And the storage will be higher, kind of captain of the obvious there. So this one is changeable. But when you change it, it doesn't change what's already on disk. So in other words, you turn compression on, the stuff that's on disk is not going to change unless you reread it. It'll remain in the same capacity, but everything after that. So this is one you can kind of play with. Also, you can query the property compression ratio just to see how good things are going. And that way it'll tell you, are you compressing well or not? And then you can make decisions based on that. So backup, it's a snap. I think most folks know about ZFS Snapshot. This is great, you know, so on your COMSTAR ZFS array, you can set up snapshots to happen automatically. You can set them up to be sort of rolling window of these. In other words, maybe you always have a week's worth of snapshots that are rolling through. There's blogs on this galore. It's amazing. When I went out and took a look, it's just great. People have gone nuts with this. They've got great, you know, scripts and everything and cron jobs set up to do this. It's kind of interesting too, if you want to keep things really simple, you can use Time Slider. So Time Slider can create snaps of all of your ZFS volumes that you have. The only disadvantage on that is that it does create a lot of them. It's kind of hard to arbitrate between how much it does create. It does them hourly, daily, weekly, monthly, that kind of a setup. So you end up with a lot of snapshots, but what it does do is it'll set a high watermark based on how full your file system is, which is not bad. And then it'll start deleting old snapshots as a result. And this is nice, I mean, because it's sort of just the no-brainer way to set up your array and move forward, right? So very, very, very simple. Send receive, ZFS send receive, you can send a snapshot and receive it to another volume. You can do that locally, you can do it remotely, you can do it to a tape device, you know, so you can set up your backup, your automatic backup with these. You can use incremental if you're sending it long distance, right? So you can compare two snaps, send that just the incremental over to the far machine to set up your disaster recovery. So very powerful command and very, very simple. Recovery pretty straightforward. You can roll, if you have a local snap, you can roll back to a previous snapshot, or if you have something remote or whatever and you want to create an up and running system, you can create a clone of a snapshot that's a read-write, and you can go off and running and start working with that file system. So very powerful stuff here. Again, they give you lots of interfaces to go work with, and it's kind of up to you to figure out how you want to use them in your array. So data validation, scrub it. So I mentioned the zpool scrub command. You can use that to do your data validation for things on disk. It'll actually go out, compare the data with the checksum, and tell you that things are okay, or tell you that things are not okay. You should factor this into your backup plan. Now it's kind of interesting. I did a little bit of research on this, just looking around the net, and a lot of people scrub their disks a lot of the time. And that's okay. There's nothing wrong with that necessarily. But just remember, you get this checksumming on every I/O that you do, right? So if you're cycling through your data pretty frequently, I mean, you're getting that for free, and the scrub is just, increasing a bunch of I/O for not a whole lot of benefit. But the way I think of it, just kind of as a rule of thumb, is you need to picture, if ZFS or zpool scrub comes back and says, nope, you've got a problem, so how are you going to recover, and figure that into your backup, right? So one rule of thumb I put out here, a best practice, you may want to do a zpool scrub halfway through your tape cycle. In other words, when you've got a fresh tape and you use it and you're ready to redo a backup on it, you should have done a zpool scrub maybe twice. But that's just a rule of thumb. Everybody has their own backup strategy, if you will, on how they want to handle things. Also, some other things here too, right? RAID plays a big role in a RAID Z2 or a mirror or whatever. You've got to have significant sets of failure before you're not going to be able to get your data back. So you need to think about that too. So don't just scrub all the time just because the internet says it's a good thing to do. Scrub when you really need it. So this is my challenge slide. Everybody has a challenge slide. This is the one that's really hard to explain if you're not familiar with the concepts. LUN provisioning with COMSTAR. So what is LUN provisioning, first of all, right? Really, LUN provisioning is where you take a LUN and you're exposing it to a specific host out there. Okay, not multiple hosts, but a specific host. And you do that for a lot of different reasons, but one of them is that you don't want two hosts writing on the same LUN, right? Could cause a little bit of data corruption in that instance, just a little. At your home, maybe not a big deal, right? You can kind of monitor that, but in your data center, you don't want that. The other reason that you do LUN mapping, and this is when you actually set up a LUN number to present to that particular host. Some applications actually want a LUN to be a particular number, especially LUN 0, especially if you're booting, for example. A lot of OSs want to boot off of LUN 0. So what we're doing then is we're basically saying, here's a LUN, I want only these hosts to see it, and this LUN has this number. That's what we're doing in LUN provisioning. Okay. Now, in this diagram, I've sufficiently confused even myself. So what you try to do here, the other thing that you try to do with LUN provisioning is you will create a host group, you add the host group members, so that's actually your initiator. Those host group members are typically 2 ports, and you'll want to do the same on your target, create a target group, and add target group members, typically 2 ports. And the reason you want a couple of ports is you also want to have some redundancy in your pathing in your data center to your particular LUN, right? So that if one path goes down, you have multi-pathing software, it reroutes the I/O and goes down the other path. All right? Once you set up those host groups and target groups, then you actually in COMSTAR, you use the host group, target group, and LUN number in one command, add a view, and then it sets up the relationship between that initiator and the target. So I hope everybody understood that. My challenge slide. One of the last features that I'm going to talk about today is iSCSI authentication. So this is very specific to the iSCSI protocol set. iSCSI authentication we do support, both in our initiator and in our COMSTAR target. We support it through CHAP, the Challenge Handshake Authentication Protocol. Basically, it supports a username and a password, and you basically can verify either at the host side or the host side and the initiator side that you are a trusted host coming in and asking for a connection. I mention this because it's not used a lot, but in the data center, it's something that people actually want to make sure of, right? They don't want a rogue laptop coming in there and being able to access LUNs or things like that. So you can't do that if you set up authentication and use CHAP. If you connect to many nodes in a very big sort of SAN situation with iSCSI, you can use a radius server, and that's actually something you can log into and make sure that you're authenticated to log onto that server and set up those duples so that you have one place to manage all of that. Okay. All right. So simple iSCSI array setup. So this is kind of a situation where I just wanted to make sure everybody understood how simple this really is. And it's not that many commands to set up a very easy iSCSI array setup, something you might use at your home, right? And plus Dan's at the keyboard, so I mean it has to be somewhat simple. We're not going to do, we do have an advanced array setup, and I did want to get to that, but unfortunately without our equipment we're not going to do that one, but we will go through this simple one. So how hard is this stuff? So next slide, we're just talking about something pretty cheap and small. 3-drive machine, 1 for the OS and 2 to mirror for your data. You're going to create the storage pool, configure COMSTAR. We're not going to do anything with data services. But this would be something you'd have at your house. The LUN would be available. You could use Time Machine. You could use it for anything you want. It's just, you could think of it as a thumb drive, right? So, Dan, with that, take it away. All right, so for this one, I really got to get close. All right, so the first thing that Dan's doing is we're just setting up our mirrored pool. Once we get that set up, okay, my pool is the mirrored pool and our pool is the OS. Now we're setting up 100 gig, basically 100 gig Z pool, which will be the backing store for the LUN. And he's calling that COMSTAR LUN. COMSTAR LUN. Now what you do, this is the LU provider that he's working with here, and it's called SBD, SCSI Block Device. So we use the SBD ADM to actually create the LUN. That'll give us a GUID back. That GUID's important. Now, this particular command, we create the LUN. Now, nobody can see it. It's not reachable or anything like that. We've got all the characteristics. We can do all this administration detail. We could have set up properties. We could have done all sorts of craziness, compression, all of that stuff, before we actually present it out to the world. This add view command, just with the GUID, is going to release it for any host to actually see. So you could actually run into data corruption or something like that. That's why you'd use this at home. This command is where you would actually put in host groups, target groups, so that you would map it to a particular initiator. But here we're just doing a simple one. ITADM is iSCSI target. So this is the port provider. And for iSCSI, you create an IQN, which is the identifier in the protocol set. And now it's ready. And Dan says nothing. And so literally 5 commands, right? And you've got to LUN out to all of your initiators. You can hook up with a Microsoft initiator. You can hook it with Mac OS. You can do it with Solaris. It doesn't matter, but it's ready to talk. And that's it. So the point here, and this is what I really want to drive home, it's really easy to administer with COMSTAR and ZFS. It's got just a ton of characteristics and power behind it. So really good configuration. Summary, yeah, so pretty powerful combination. I think you can definitely see, setting up a low-cost array, very little dollars, get a lot of advanced data services. There's more information out at the COMSTAR project page, and of course ZFS is all over the map as well. A couple of things we just briefly touched on, but I want to bring home. So since this OpenSolaris 2009-06 got cut in terms of it went out the door, we've actually done some pretty good work in both ZFS and COMSTAR. Encryption's on its way in ZFS. Deduplication is pretty close. With COMSTAR, we've got, again, 3 more port providers in FCOE, ISER, and SRP. So things are really moving. So next release will be even more powerful with COMSTAR and ZFS. So look for that. And in fact, get on and point to the dev repository and pick that stuff up now, because most of it integrated just right after 2009-06 and Bill 112. So you can pick it up already. And with that, I'll take any questions you might have. The one thing I would ask is that you go to the microphone. This is being recorded, kind of hard to hear. So if you have any questions, let me know. If you want to drink beer, we can do that too.
Hi, Scott. You covered off as far as I can see, you covered off 2 different ways of stopping your LUN falling into the wrong hands. You did the LUN masking and mapping, which is old school, which I'm used to from logging into a RAID array and actually doing that. And then you did CHAPS authentication. So are those 2 orthogonal to each other, or would you do both in a data center?
So I think, boy, is it hard to hear, I have to tell you that. So I think you're asking to prevent rogue warriors coming out there and accessing your LUN. You're seeing 2 different techniques, and would you use one, both, or which one would you recommend?
So, yeah.
Okay. So in the industry, I'll give you kind of the industry answer, and I'll give you, my thoughts on this too. The industry actually uses LUN provisioning. That's what they use 9 times out of 10. And they don't use, for example, iSCSI CHAP administration all that much, because if you look at all of the different connectivity technologies, right, iSCSI authentication is only in iSCSI, right? So it's not the same for fiber channel, it's not the same for SAS or other things. And so typically you don't see it used all that much unless you're using the same internet connectivity through your data center to out to everything as you are for iSCSI. In that case, you kind of want to double up. You not only want to provide LUN provisioning, but you also would use authentication on iSCSI. But if they're separate, I wouldn't use the authentication. It's a good question. Any other questions? Yeah, go ahead.
So how does the performance of the ZFS RAID compare to like hardware RAID, like a 3-wear or LSI card, you know, if you were to set up this storage on the cheap?
Boy, that is such a loaded, it's a good question, such a loaded question.
If you were trying to do some low cost.
It is an important question. You know, there's a couple of things to remember here too. One is that you need to think of a RAID card just like running the Solaris OS 2, right? I mean, it's running an OS inside the RAID card. Don't forget that. There's other things about the RAID cards too. So performance-wise, which is a good question, is one aspect. The dependency on power and battery backup and everything else is another one too, right? So you can potentially have reliability problems with RAID cards, especially for $450. But on a performance basis, and you know, if you allow the use of SSDs and everything else, I don't think you're going to see all that much difference between the two, especially with COMSTAR. So one of the biggest changes that we've made, and we didn't really talk about it in this presentation, but if you look at 2008-11, we used a userland iSCSI target at that point in time, right? And we coupled it with ZFS there too, so it had all the very similar characteristics. But COMSTAR is in the kernel. It's actually improved the performance like almost 3 times of what it used to be in 2008-11. So we're very, very, in fact, we've measured up against other iSCSI RAID arrays with ZFS. And of course it matters on data. I mean, I could win a benchmark, you could win a benchmark, you know, it all depends on what data and pipes that you actually put through it. Well, we're actually not seeing anybody that we can't pretty much beat from an iSCSI RAID array perspective versus COMSTAR with ZFS on the back end.
Also, you mentioned multipathing.
Yeah.
I assume, you know, if you added multiple NICs, you could take advantage of that or do link aggregation for performance or fail.
Yeah, so, boy, I can quickly get out of my expertise here, but yeah, if you put in multiple NICs, right, on your initiator, you can use, for example, you can use MPX-IO, because MPX-IO is basically LUN-based. So it's that GUID we created. It looks at that GUID and it says, oh, I see that GUID twice. Oh, okay, so then I know there's multiple paths. All right, that's one way. But you also have IPMP, right? So you can use sort of the TCP/IP characteristics underneath to aggregate those 2 NICs, you know, so if one fails or whatever. Now, we don't do multiple connections per session right now because MPX-IO and MCS are so close in characteristics that we're probably not going to support that. But yeah, you're right. Multiple NICs, you get that. You get a switch, you know, single NIC with a switch and multiple cables to 2 ports. You also get multipathing there too. It's good questions.
Hi, Scott. Could you elaborate a bit on the status of FCOE?
Yeah, it's actually put back in build 112. So I'm thinking, gosh, I wish I knew when we're going to open up the dev repository and move it. Because right now, if you look at the dev repository, it's pointing exactly to build 111. Yeah.
Because if I recall, the port provider is available in that build, but the client, the FCOE client, wasn't.
That's correct. So yeah, if you want end-to-end inside Solaris, FCOE initiator will go back about build 122. So that's about August. But FCOE target's there now.
Okay, thanks.
So.
Any other questions?
All right.
All right, thank you all for sticking with
Thanks,
us
everybody.
through a long day. Thanks, Scott and Dan, for